Welcome to Chemistry at Hononegah High School. I'm Brian Brown, and today we'll be finishing up our notes dealing with writing, balancing, and predicting the products in chemical reactions. Now, what we're really doing in this last step is very similar to what we did yesterday, but yesterday we knew what the substance was, or what the reaction type was. So we had limited information, but they said this is combustion, or this is synthesis, or whatever. Well, in many situations, you're not going to be given all of that information. All you're going to see is I've got this as a reactant or these as reactants, and that's it. So from there, we have to put it all together. So what we're really going to do is first identify the reaction type from limited information. And remember, the purpose of the reaction types is to establish a trend. Then we can use that trend to figure out what's going to happen. And then finally, like always, after getting the right products formulas, we end up balancing to look at how it looks in the real world. So we're going to do this in a very specific order because I think it helps it's easier basically if you do it in a certain order. Like hydrocarbon combustion, not only is it a quick, easy one to do, and that's useful to do at the beginning, but it also makes single replacement a little bit easier later on. So first thing we're to ask ourselves is, are oxygen and a hydrocarbon the reactants? If they are, if I have O2 and a CH compound or a CHO compound, then I know it's hydrocarbon combustion, and in complete hydrocarbon combustion, I always get CO2 and H2O every single time. So they give me my reactants, I know what the products are going to be, I copy and I balance. Second one we're going to look for is if it's not hydrocarbon combustion, ask yourself, do I only see one reactant? If it's only one reactant, it has to be elemental decomposition. And it's the only type of decomposition I would expect you to do. So is it a simple two-element compound? All you can do is break it apart into its elements. Don't forget, unlike the last one where we always get the same formulas, we got to ask ourselves, what are the formulas of the two substances we're making? Since they're both elements, it's about diatomic. So are they on Fickle-Bry? Next one we're going to look at is synthesis. So are the reactants both elements? So now we're going in the opposite direction. If I have two elements at the beginning, all I can do is fuse them together to make one compound. So combine our elements to make a compound. Remember the cation, the metal has to be listed first. And we're making ionic compounds, so we've got to look up the charges, crisscross reduce. Every single time we make a compound, we have to check that so we get the right formulas. So don't forget, in our synthesis, we're making one ionic compound. You've got to put it in the right way and look up the charges, crisscross reduce, to get the right formula so it balances properly. Fourth one we're going to look at is single replacement. Now, if I've already ruled out hydrocarbon combustion, I don't really have to worry about, is my element O2. I can just say, do I have an element of compound? If it's got an element of compound and it wasn't hydrocarbon combustion, it's got to be single replacement. Now, single replacement, you have to remember there's extra work here. First, you need to see if it occurs. So you have an element, and that element is attempting to replace a like element in a compound. And remember, the ones we're always looking at are metals, so it's attempting to replace the first thing. So you ask yourself by looking at the activity series, is the element more reactive? Is it higher on the list? If it is, a reaction occurs. If it's not, you just put NR. So this is the one where we have two options. Either the reaction occurs and you're going to replace the like ions, and therefore you're going to get a new compound. Check your charges, crisscross reduce to get its formula. And the old substance in the compound is going to kick out, is now alone as an element. Ask yourself if it's on Fickle-Bry. So we got to do both things here because it's an element and a compound. But remember, if that elemental substance is not reactive enough to replace the metal in the compound, it's a no reaction and you're done. It's that quick. Now the last one is double replacement. Easy to apply, but a little more work because we're making two compounds. So finally, ask yourself, are the reactants both compounds? If they are, it's got to be double replacement. And what you're doing is you're trading the cations in each case. So the cations and anions end up with new pairs. So just swap the cations, and we're making two new compounds. So two times you have to check charges, crisscross reduce. Check charges, crisscross reduce. And once you've got the right formulas, then you worry about balancing. So these are the steps to follow if we're given very limited information. And yes, you can do them in a different order if you want. And as you do in practice, it'll get easier. But you need to understand that while at the beginning it's okay to use this chart, eventually you need to get rid of it and be able to do it on its own. So practice it enough so it makes sense and you can do it. And that ends our last set of notes on the chapter.